So in this video, I'm going to try and find the maximum and the minimum value assumed by this particular function, and it's within the domain of -2 to 3 for x. So there's two kind of options for where a global maximum or minimum can happen. So one option is it happens at a stationary point, and the other option is it happens at the boundary points. So in this case at x equals -2 and x equals +3. So what we're going to do is work through identifying where the stationary points are and then identifying the boundary points, and from that we'll be able to gather what the global maximum and global minimum actually is. So let's start off by writing our function out. And what's going to help us is actually expanding this out, because we're going to need to take the derivative in a moment anyway. So expanding this, what I'm going to do is leave the x out the front, and I'm going to multiply these two brackets against each other. So we're going to get x squared, it's going to be minus x, and then the next one will be plus x, and then minus 1. I think I'm going to get some cancelling happening. And now if I multiply this x in, I'm going to get x cubed minus x. So that's my function. So let's start this off by looking at what the stationary points are. So we can identify stationary points by solving for where the gradient is equal to 0. So the gradient of this function we can get just by taking the derivative. So y dash, it's going to go using our power rule to 3x squared minus 1. And we're going to let this y dash equal 0 for where the gradient is equal to 0. So now it just becomes a case of solving for x. So I'm going to shift the 1 to the left hand side, and I'll divide by the 3. And then I want x on its own, so I'm going to need to take the square root. And remember that we can take either the positive or the negative answer for our when we take the square root. So that means we're going to get two answers coming out here. One is going to be the positive, 1/3. And I'm just going to put this in decimal form. So it's going to be about 0.577 approximately. And the other option is when we take the negative. So it'll be negative square root of 1/3. And again, if I convert that into an approximate decimal, it will be -0.577. Alright, so my next step is going to be figuring out what the y value is that corresponds to each of these. And we should be able to get that by going up and substituting into our equation for y equals. So let's do that. So y equals, it was x cubed minus x. So for this first one, in a calculator, it comes out to approximately -0.385. And if I do the same thing for the second one, the slightly different x value this time, what we find is that we get a y value of 0.385. Right, so we have our two stationary points. And their coordinates are, the first one is 0.577, -0.385. And the second one is at -0.577, +0.385. Alright, so one thing to just double check is that both of these points actually lie within the domain that we're interested in, because if they don't, then we can automatically exclude them. So looking at this and comparing it to our domain, which is between -2 and 3, we can see that they do actually fit in there. It's about -0.5 and +0.5, which fits right in. Alright, so we said right back at the beginning of the video that the other option for where a global maximum or minimum can occur is at the boundary points. So we're going to need to go through and solve for those to get our other options out. Alright, so let's start with using x is equal to -2. So all we've got to do is figure out the y value that this corresponds to. So I'll substitute it into our equation for y. and this one works out to be -6. And if we do the other value, which is 3, this works out to be 24. So now we can see that we have our boundary points at -2, -6, and at 3, 24. So now we just need to have a look at what the absolute maximum and minimum points are that we can find. So again, we've got these 4 options down here. So let me just drag this down a bit so that we can see them all at the same time. So what we're looking for, if we're looking for the global max first, is the biggest y value out of our options. So looking through these, I think the biggest one that we can get is going to be 24. So that's going to be our answer for the global maximum. And then global minimum, again, out of these 4 options, we're looking for the smallest y value. So this is negative, that's negative, but it's less so. So again, this one is going to be the global minimum. So they're going to be my 2 answers to the question. So if you wanted to do a quick double check of your answer, you could flick over to Wolfram Alpha to have a look at the graph. And this is what I've got here. So I've plotted my function within the restricted domain. And what we can see is, yes, the minimum value is definitely happening at the left-hand boundary of -2. And the maximum within this domain is happening at the right-hand boundary, which was all the way up to 3. So actually it's all the way up here somewhere. What we can see is that the 2 stationary points or turning points that we identified, they are kind of locally minimum or locally maximum, but yeah, they're nowhere near as big or as small as the boundary points. So that's pretty much all there is for this video.